Welcome. This is Rob Sabre talking a little bit about testing in the dark. And I'm sure you've been there, I'm sure you've seen it. Projects where you have just hardly any information, and yet you're challenged by your stakeholders to test it. Sometimes it's software that came to you from a third party source, sometimes it's software that's been around for years, sometimes it's software that is being evaluated to assess perhaps is the company a good company to invest in. There's all sorts of reasons projects come to me and I'm asked to test it, and I have absolutely no idea and no knowledge about how the software was built, how the software was developed, who developed it, why it was developed, and for of course limited information. Limited information. I have very vague understanding of what the requirements are, sometimes to the point of only knowing the name of the software. Literally, one time I was asked to test a web editor, and all I knew is it was a web editor called XYZ Editor, and that's all it was. And I had to test this, and this was an acquisition. Someone was not just going to be buying a license of it, they were going to be acquiring the company that created this web editor. And I just really had no notion of what it could do. And so I used some principles which I'll share some of them today, to test in the dark, to test without knowledge of like traditional requirements or traditional design, nothing following the IEEE standards, no history on testing, very, very vague idea or notions of what the products start with. And then what I want to do is I want to build on that. So usually the pain for testing in the dark, what I see is the project comes to you and you don't have any traditional information, but also you might have traditional information, but it's out of date or not trustworthy or somehow born to be used by different persons than you. Like someone wrote this, but it doesn't seem to have any bearing on what the application is. And I believe me, I've seen some weird regulated projects where you start reading whatever documentation they're giving you, and it has very little bearing on what the product is. Now, for me, testing is learning, right? So when I'm asked to test, I'm asked to learn about things. And so testing in the dark is learning without a whole lot of information at your disposal. There's some useful metaphors that I'd like to keep in mind. So just the fact that I say testing in the dark, I mean, that's a metaphor. I mean, there's always a little bit of ambient light somewhere, and maybe we've got to use that light and focus it. So we've got to maybe get certain tools to sort of amplify whatever luminescence there is around us, like those beautiful military binoculars that people use in all the movies every day. There's metaphors related to testing being like car headlights. And when you're driving through the mountainy regions at night, the headlights point to the road so you can see what's ahead of you. And perhaps as a tester, what I'm going to do is learn about things. And maybe as I'm learning about things, I'll build a map. I'll build a visualization of what I'm learning about as I go. And maybe I'll identify what I think are issues, and they'll be like my road hazards. And I'll share that with my stakeholders, and I'll try to converge on things that matter. As I learn more, it's like the fog is lifting. I don't know if you've ever had a chance to drive through the mountains of northern Quebec in a beautiful summer morning. You're going to start off there at about like 4:30 in the morning. And it's all fog everywhere, and then by about 6:30, all the fog is gone. But between 4:30 and 6:30 in the morning, that fog is gently lifting, and it's actually terrifying because you if you're not familiar with the roads, you don't know. You see a little bit of what's coming ahead, and then all of a sudden you're back in the fog, back in the fog. So I think one of the metaphors I have is that as I'm testing, I'm learning things, and this is sort of lifting the fog a bit. It doesn't completely remove it, right? It just lifts it a bit so that your visibility is changing. And of course, the more you learn, hopefully, you can refocus and adapt and learn stuff that matters. The notion of recon, or what's military recon, something made famous in the movies, where people do reconnaissance to learn things, what's going on the other side, all sorts of World War II recon motion pictures that talk about the daring adventures of people to try to understand what's going on behind enemy lines. Well, here in recon, I like to say, let's figure out ways to learn about it, to get reconnaissance about it, and then to take what we've learned and again, try to build a map, try to build a visualization of what's going on, but at the same time, share what we learn with the stakeholders to make sure that we're learning about the right things. And they don't know necessarily when they asked us, are they learning the right things? I like to also consider instrumentation. I had a chance to navigate Canada's largest registered ship for a few minutes in open seas in the Gulf of St. Lawrence, a couple of 100 kilometers across from one end to the other, and in a complete fog. And we were able to navigate, of course, not by sight, but because there was just so much instrumentation. And while we're testing, we have all sorts of ways that we can use perhaps dynamic analysis tools to help us understand what's going on and how the software is using resources around us. And so there's different things that we can use, different tools we can use to make things visible which otherwise might not be something you can see. And of course, navigating ships in open seas is done with all sorts of instrumentation these days. Now, when I'm testing in the dark, I feel something special. I've been asked to test in the dark. Someone said, "Hey, Rob, could you please test this?" And whoever asked me to do that, whoever asked me to test it, demonstrates one very important thing. They demonstrate to me a level of trust. So I'm being asked to do something, and they trust that I know what I'm doing. They may be asking something that they're very ignorant of. They may be very ignorant of how I do my job. They may be very ignorant of how technical people create products. But they are trusting. And I want to start and build on that. I used to think when I was asked to test things and I was just given the name of a project, I said, "Please test that." And I said, "What? That's not enough information." And I would kick the project back to my stakeholders and say, "I need more information before I can answer your question." But then I started learning, wait a sec, actually what the stakeholder needs is help and guidance. So sometimes what I've got to do when I'm asked to test in the dark by a stakeholder is help the stakeholder learn what questions and what concerns they should have about the product around them so that we can get things done, so that we can make their goals to achieve whatever they want to accomplish with this testing of software. So we're looking at basically questions like who. We can ask these questions to the stakeholder. Someone asked me to test, right? So who am I testing for at the beginning? Someone asked me to test. This testing in the dark doesn't just magically happen. I don't just walk into my office one day and see a piece of paper saying, "Hey, Rob, test this," and it doesn't say who. If it doesn't say who, I can just do nothing. Eventually, someone will come and say, "Hey, Rob, I asked you to test this." Who asked me to test it? Once I know who, I can basically now start working with them to try to understand all the elements of the dimensions really I need to start learning about the product. Maybe it's important to know, for example, where the money's coming from. So show me the money. Who's paying for the product? Is there a customer paying for it? Who is that customer? Why are they paying for it? What value are they going to extract from it? Now you're starting to see questions that could be asked of stakeholders around the project, which will give you insights as to what may matter or may not matter in terms of your testing. Who's paying for the development? Who's paying for the testing? All of these are different parts of the same question. Is there a stakeholder who's putting money on the table to get this job done? What value are they expecting to get for that money? Also, I'd like to know who's developing the software, if I can. Sometimes there's nobody, by the way, developing the software. Sometimes you're just given a piece of technology that someone found, an open source piece of technology, and they want to know if if it works, if it does it do what it's supposed to do. Of course, they don't know what it does or what it's supposed to do. They're asking you to test it in the dark, right, about that. So it's important to look at the who. So who are we testing for? Who matters? I want to know who the user is. If I can find out who the user is, I can basically say, okay, who is the user and what does the user want to do with this? How does this software help the user get their job done? This is the type of things I can do by interviewing users. And whoever asked me to test this stuff in the first place, of course, that's the what I call the stakeholder who's like my sponsor, my product owner. Someone has asked me to do it. So if you start understanding the who's, then you can start using your knowledge of the who to understand the whys. So the whys are really basically things like, why are we being asked to test? Why was the software created in the first place? Why? Is there a why there? And that why very often has to do with notions of quality. Ever since I've been involved in software engineering, since pretty much the dawn of time, I've been concerned about issues of quality, and I've come to realize that Rob Sabre's personal opinion of quality might not be what matters on this project. Maybe what matters is what my stakeholders believe quality is. And maybe they need some help in describing it. Not everybody knows how to describe quality beyond saying it's some sort of a slogan. So quality could be many things, and it's different things to different people. And I don't want to say there's any right or any wrong or any judgment here about what quality is. Sometimes the best way to learn about quality is to talk to people and to watch how they make difficult decisions, or to learn how they make difficult decisions. You start understanding better of what quality is. I think that I've identified over 15 different views of what quality is, and some of them are almost contradictory. One view is quality is conformance to requirements. Phil Crosby, Total Quality Movement. One is quality is suitability to purpose. Joseph Juran, and by the way, the behavior-driven development community has that sort of view of quality. One of them is quality is value to stakeholders, which is a very general, broad description held by many people like Jerry Weinberg and Tom Guild. Different reasons to sort of different issues might come and different strategies might come out of your knowledge of what quality means. Because if you believe testing is to provide knowledge about quality or information about quality or learning about quality, then you might say, well, if quality is conformance to requirements, my job is to hunt for requirements. And there's all sorts of things. Even in projects that have documented requirements, there's usually a lot of hidden implied requirements that are not written down that must be adhered to. So hunting for requirements becomes a very important thing when your view of quality is conformance to requirements. And by the way, if I find my stakeholders are telling me the very little information about the product, but they believe quality is conformance to requirements, it's probably a huge part of my job to learn what those requirements are. And I'm not saying to reverse engineer the project. I'm saying to reverse engineer the intent. Like, why is this there? So this is a hunt for requirements. If suitability to purpose is the view, and this is a lovely view of quality. It's very popular today in Agile world, especially as I said, BDD, behavior-driven development. Well, different people do different things, so different strokes for different folks. And what I want to do is I want to sort of study who are the users and what do they do. Ask not what the software does for the users, but ask what the users do with the software. And when we're doing suitability to purpose, what I'm trying to do is build a model of what the users are doing with the software. Build a model of the user's workflow. Look at it from the user's perspective. Don't look at the menus, dialogues, and controls, but look at who is the user, what do they want to do, and in what situation or what context. So you actually meet the users and see what they do. And you could very quickly start building a beautiful catalog of usage scenarios. And the amount of detail you might work on is saying, once you've got a bunch of usage scenarios, then you go back to the person who commissioned your testing and start saying, well, how could we rank the relative importance of these scenarios? And it's amazing that sometimes stakeholders start having very different views of what the system should be used for than the intent of the users. Value to stakeholders. If that's your definition, and this is a little bit of all-encompassing, so some people say this is like their hippy-dippy definition of quality. But if it's true, if this is what your primary stakeholder tells you matters, well, then your job is to do the same as I said about users, except find out who are the stakeholders and what do they value. And it's interesting to note that what different stakeholders value different things at different times. So it's important to situate yourself in time, in terms of time of the project or in real time of the calendar, and different stakeholders come in and out of things. If you're at the end of a quarter and you're a publicly traded company, there are stakeholders who want to know if your product is something that's shippable so that they could put the development cost in as capital in the financial statements, which you can't do if the product is not shippable. So you have different stakeholders only show up at different times. They're not always there. And what they value is time variant, which is really cool. As if this is the case, then you sort of got to walk into the office every day and come and say, "Hey, what business are we in today? What matters today? Because it might vary as you go. And you got to be very careful with this type of view to sort of be careful about building up too much emphasis on one set of values. I like to suggest that people use just-in-time test strategies if this is the case, so that you can basically wait till the last responsible moment to put together your testing. Now, this is not saying to procrastinate. I don't want to give you a license to procrastinate, but sometimes you want a detailed thing at the last responsible moment. What matters? So we've got an idea now of who, we've sort of got a view of quality. We know different views of quality will help us identify what types of things we might want to look for. What are we actually testing now? It's an interesting thing. Is there a problem that the software is supposed to solve? Are there objects? Are there things that are in scope and out of scope? Are there variables that are particularly concerned? Are we concerned about, for example, accuracy of tax calculations? Are we concerned about some objects that are in our control and some are out of our control, and the scope of the testing should be in the stuff that's in our control? So this is like a scoping issue. And variables for me is something I am always hunting for variables. Variable being something that can change, which could influence or is influenced by the behavior of the software. And even if you do have, by the way, documented requirements, there's very rare that they have a very complete set of the variables that matter available to you. So you're always in the dark a bit about variables. There's issues about where that matters. So this is something that I've spent 10 and a half years in multilingual computing, and I found that the environment and locale that the software is going to be running in is absolutely critical. And I've seen cases where unexpectedly weird problems happen just because of this. So sometimes knowing the sort of target environments of software can give you some guidance, at least into perhaps the type of risks we're looking for and strategies to look for them. So we can do platform compatibility testing without having to go through all of the functionality in an application. We might just identify 2 or 3 key functions and then be able to do a lot of environment and platform compatibility testing if that's what matters. And the where we're testing includes data, network state, platform, any state variable that basically could change around which the software is operating. When matters. I think that this is a critical thing in a project. What is the timeline? So when do we start? When do we end? And this is very awkward in some agile contexts where teams don't want to tell you, when, because they all they want to say is, well, every sprint we're supposed to have a working shippable project, but when are we going to have something we can sell? Well, that doesn't come from the agile development model easily. So what is the timeline, and who established that timeline? Is there indeed a deadline? Often when I'm given something to test, I'm given a deadline that's absurd, that has no basis on the amount of work I have to do. But that doesn't mean it's not unreasonable. It may have a basis in business. When I was in the garment industry, the clothing industry, the clothing design industry, I found out that there were some really crazy deadlines that were imposed by seasons. And if you didn't have your designs at the manufacturers by a certain date, you would miss the whole season. So some deadlines are business critical to the point that if you miss that deadline, you're out of business. Other deadlines are a bit more soft. They were set by some marketing person because they're going to be doing an advertising campaign online, and it's very soft. It could be easily moved. So we have to understand the deadlines. Maybe there's a history of the project. What happened before? A little bit of archaeology here might be in order. Learning about this might be useful in identifying the who's and the how's that we got to the point on. I love to find someone like a senior architect or a senior developer and take them out to lunch or take them out for a beer after work and basically just take a look and jam with them about the history of the project. And even if they're not providing you with technical details, they're providing you with key milestone information and key bits and pieces that can be then used to hunt down maybe significant technical information about risks, about things that can go wrong, or about things that are valuable, that matter to the business. Understanding the product's use, and does the product's use vary with time? And there's a lot of systems that have some features that are only used once a year at the end of the year. Typical accounting packages, year-end stuff happens only at the end of the year. Tax stuff happens at the tax time of year. So there's whens related to the use of it. And there's also dependencies. So dependencies, this project depends on that project, this technology depends on that technology. My mobile application runs, but the server has to be active and I'm dependent on the server. If the server is not operating, my mobile application will not operate. Try to use a product like Waze when you're not connected to the server. It's awkward, it can do a little bit of stuff, but it's awkward. It needs connection to the server. It needs connection to GPS. It has dependencies. And of course, that leads you to some interesting testing is, well, what if that dependency is not there? You can actually start learning about the behavior. And even if you don't know what the expected result is, you can say, okay, let's do this test with the network on, and then let's do exactly the same test with the network off and compare the results and see if it's meaningful. When matters. Past, present, and future. I think there's notions of transaction timing and synchronization that matter. I think there's all sorts of things also with data that matters. Transactions could be completed, they could be midway, they could happen in the future. So I want to look at the importance of time on transactions. Some of the things I like to play with is, for example, sending an email to myself. And I might be in the airport at Auckland, New Zealand, and I send an email to myself, and then I land. The plane lands in Vancouver, Canada. I go to the lounge in Vancouver. I check my email, and I would have received the email before I sent it because I went around the world against the clock order, and I basically bought myself a day or something like that. So we have interesting time things, and maybe time doesn't matter. It's how matters. There's issues of how the software was built and constructed that can give you insights into technical risks. It can give you insights into what can break. And so we can look at, did we buy components? If we bought a component, maybe someone who sold it to us has some sort of a contractual obligation to us. We might have information in very unlikely sources for that. Have we changed things? Have we integrated things in? What life cycle model are we using? All of these are basically, for me, indicators of technical risk. And I'm a sort of a hound for change, whether it's change that we can describe or change that we can assume. But I still like to know what has changed, learn what has changed, hypothesize what has changed, and basically study what has changed, how that impacts features, functions. And I'm looking for unexpected consequences of change. Context matters. The exact same project with different business, technical, organizational, cultural, or project governance rules could be very differently managed. One of my favorite examples is the iPhone 4, which was released in 2010 by Apple and helped them make, I think it was an order of magnitude increase in their gross profit that year. And yet the phone did not work. When it was released, there was a bug in it, which is now known as AntennaGate. And that bug basically would render the phone useless for making phone calls. But what turned out was that Apple was selling their phone to early adopters of new technology who were really excited by using things like FaceTime and different techniques and technologies, but weren't really worried about brick and mortar, backward compatibility. Now, if that same product was sold to a different market segment, dramatically different behavior would be observed. The Bank of America wouldn't have tolerated the failure of the phone to make voice phone calls. But as it was, because they were selling to early adopters, and the marketing segment they were after, people actually loved that and would post YouTube videos of them discovering the failure. It was all really cool stuff going on. So context really does make a difference. In my experience, when I'm testing the dark, as I learn more, I basically get a better picture of what matters. I have to learn a lot of things. Like I have to learn about who should I talk to about prioritizing stuff. This is important. It might not be the person who asked me to test. It might be some other stakeholder. But I definitely don't want to do this on my own if I'm in the dark. I want to learn how to organize and prioritize and focus my work. So I try to blend two things. ASAP as soon as possible, and ALAP as late as possible. And what I try to do is as soon as possible, as soon as I can, I try to collect and identify different types of testing ideas, all sorts of possible things to test. So as early as I can and forever and for always, and I never stop. Even while I'm testing, I find the best test ideas while I'm actually testing. So I keep collecting test ideas, but I don't elaborate them or turn them into executable tests, whether I'm using scripted testing, automated scripted testing, or exploratory testing, or whatever way I'm going to document my testing, to describe my testing. The elaboration of that, I would wait till the last responsible moment. And this is not a license to procrastinate. I am not saying deliberately delay your project here. I'm saying wait till the last responsible moment to detail it. Otherwise, you may have to do a lot of rework as you learn more stuff. So basically, by waiting till the last responsible moment to detail and elaborate your testing, you're going to, in my experience, you're going to minimize rework. Testing in the dark implies here that I've got to sort of find lots of ideas. So I try to get tons and tons of different testing ideas, and I like to collect them and organize them and sort them and shuffle them and sometimes prioritize them. And where do I get these ideas? Well, I try to build a notion or a hypothesis of what the system is supposed to do, or what the system is not supposed to do. If I've got knowledge of how the software was built, then I can sort of say, how can it break? What is the weakness? Are there areas of weakness? Are there areas prone to failure? Are there areas that have had a lot of change that might be riskier, technical risk? I want to ask questions about how the system reacts to its environment. What characteristics must the system have? This is non-functional testing. Things like performance, reliability, scalability, security. All of these are characteristics. Just because they're, by the way, hard to test doesn't mean they're not important test ideas to identify. I might look if I've finally got a handle of, okay, what is this purpose of the system? I might ask the question, how have similar systems failed? And practitioners in testing have put together gorgeous collections of how systems have failed in the form of taxonomies. These are beautiful collections of bugs that you can find and see, hey, how has this previous similar system failed? And I could come up with a beautiful test. If I can see a bug that happens in a similar system, then I can set up a test that basically confirms or refutes the hypothesis that that bug exists or does not exist in the software under test. And I can do this without having any requirements, hardly any knowledge at all, just a good, healthy bug taxonomy. And there's a whole bunch of taxonomies on the market. There's mobile device taxonomies, transactional e-commerce taxonomies, normal software taxonomies. There's dozens of them. All of them are in the public, not public domain, but they're open source. And they're gorgeous sources of information. You also have knowledge, how previous projects may have failed in your organization. Look at the problems people have had on previous projects. Look at bug lists from previous projects. Look at information from the support department. This can give you guidance as to what might be interesting to test, again, without going through any sort of normal analytic chain. There's all sorts of types of testing ideas that you can come up with, right? Cross-story interference, workflow, Pareto. What are the 20% of the transactions that happen 80% of the time? Sequencing, orders of operations, tons and tons and tons of them. I like to say that testing in the dark doesn't mean you don't have a wide variety of test ideas that can come up with. So come up with a wide variety of test ideas so that you can prioritize them and identify the ones that are the most important. When we're testing in the dark, test ideas can come from places and questions like these. So will data be shared with other software? Will processing resources be shared? What are users going to do with the software? Are users familiar with the problem the software is solving, or with the solution that the product offers? And then you might model your users. Are there different types of users? Are there different categories of users? Are there novices and experts and typical users? Are there installers of the system? And all of this will guide you towards different usage of the software, which are things then that you can design tests to confirm or refute that can the user do this thing with the software. And you can apply all sorts of cool test design techniques once you know what the usage scenarios are. because you could identify what are the variables related to those. This is more questions about whose. Configuration management of software and data. When you get data, where is it coming from? Where is it going to? Are there elements in the software that we don't need? And this happens all the time. When Oracle Financials gives you a new release, you might want to test it to make sure that your workflow still works, but there might be thousands of features that you just don't use. So it doesn't, the compatibility of it in your environment might not matter. Non-functional needs. So this, again, we're going back to the type of test idea for performance, reliability, all the ilities, usability. Today we see fantastic test ideas around power consumption. Power consumption can be tested in most mobile applications without knowing anything about the application, just by watching the battery before and after doing transactions with dynamic analysis tools. Environmental concerns, this is all stuff that we basically address types of ideas. So the locale, does the software replace something? Maybe we don't know about the software that we've got, that we just got, but we know about the version, the old software that it's being replaced. So we could learn testing ideas by just looking at how did people use the old software that's being replaced. Or maybe there's a documentation about what the old software does that we can check, does the new software do what the old software does? And then maybe we can figure out how to rank and prioritize that. So sometimes software also replaces hardware, so we've got to be sensitive to the fact that what's encapsulated in software sometimes includes what used to be hardware. And in old mainframe systems, it also used to include things like the operator, who was encapsulated in the software. Then we look at maybe statements of how does the software solve a business problem? Do we automate manual work? Does the software purchaser understand the sort of risk of using this software? Is it a custom version or a repurposed version of technology? Once we've got a lot of ideas, we have actually stirred up our reconnaissance. So reconnaissance is really identifying, testing ideas. I think you should always do it. The less in the dark you have doesn't mean there's less interesting test ideas. And sometimes the test idea you identify while you're testing, the test idea you identify, has more value to your project than test ideas that you've already cataloged and identified. So in recon, want to find users, learn test ideas that matter, learn what users really do, learn what varies, what changes, and then try to identify capabilities of the system that map to those things. So this is reconnaissance, learning about these things and building visualizations of them. Discover strategies to assess correctness. It's not just knowing what to test. How do you know if it passed or failed? And we can learn about these things by looking at maybe how previous or similar projects have failed. Maybe we can look at claims people make about the project, especially marketing departments might have these lists of claims that they make, and we can find that and say, okay, let's test to see if the claims are valid, are being made. So sometimes you might want to look at assessing correctness specifically, and you don't have an expected result. You're in the dark. Well, maybe you can have a strategy like the lifelines of Who Wants to Be a Millionaire, where you basically might call a friend. What's that mean? Well, while you're testing, have access to a subject matter expert or have access to a test domain expert whom you can call while you're testing to give you some guidance. Not to test with you, but to be available to you while you're testing. 50-50, the eliminate incorrect answers. This is basically comes from domain-specific rules of thumb. The answer to this problem must be a positive number. If it's negative, we know it's wrong. I don't know what the correct number is, but I can tell what the wrong number is. So this is like Sherlock Holmes would have said, eliminate the impossible, and whatever's left, no matter how improbable, must be the truth. So we can use guidance there. Eliminate incorrect answers. Learn how to identify something that's wrong rather than proving that it's correct. You can find a problem without necessarily knowing the expected result. And then assessing correctness also sometimes involves consulting groups. And James Surowiecki wrote a beautiful book about how to get a wise community built, basically of a set of peers who have learned the same about the same sort of domain, but from different sources and different approaches individually. And by consulting them, usually if you could frame things with a go, no-go sort of decision, you'll find that a wise group of people, even if it's relatively small, can point you in the right direction without necessarily knowing always what the correct answer is. And surprisingly, this fits perfectly into the model, totally by coincidence, by the way, of something like an Agile Scrum team, which has a small group of peers who are supposed to work closely together. So when you hit a conundrum and you're not sure, does this look right or wrong, consult your peers, frame the question, give a little lightning talk, and then see what they cook up. So consulting your peers. Very often we have no clue, but we can use guidelines, rules of thumb. So these are called heuristic models. Polya wrote a beautiful book on this in 1945, and that work was taken and applied to software testing through the 1990s, heuristic modeling. It's quite popular today in the world of software testing. Although heuristics are rules of thumb, they are fallible but useful. They guide your exploration. They help point you in the right direction, but they're not perfect. So you've got to realize that they're useful but imperfect. Also, another thing I think a skill that the team should have is the ability to do exploratory testing, which is a blending of concurrent design, execution, and interpretation of test results while you're learning about the system. And this is of course building models and checking to see if the models are correct or wrong or right, and learning and adapting as you go. So what I test next always depends on the results of what I tested before. We call this charter driven because the charters are like the goal, the mission statement for the testing. And we usually do this in time box sessions, which usually are a couple of hours, but they could be short, maybe 30 minutes, or long if you're doing especially non-functional stuff of a couple of days. The basic steps, you go through with this type of exploratory testing is we have like a kickoff meeting, the environment set up, we run our time box session, we collect information about what we've learned. Then after the session, we debrief and review what we've learned, and we basically try to build a map and keep going. Like after a session, you might ask your question, should we do another session? Should we move to another charter? Did we learn enough? Maybe we have some new ideas. We should certainly update our models, and we should decide, should we continue testing another session on the same charter or move on to something different? But always, always update our models and share them. We would also afterwards, of course, update if we have a dashboard, things like top 10 lists, the top 10 problems we've identified, things that an end user or an installer or a sysadmin might be bothered by, any bugs we found, we might have put in whatever appropriate bug tracking tools we've got set up. Maybe we've got claims. We've got a chart of claims. We want to say, hey, we just demonstrated that this claim is true about the product. You claim that you can do this. Here, we've demonstrated we can do this. And also, after every session, you check, is our focus right? Are we going the right direction? So we have this sort of flow of, as we're testing, we build maps. We build some sort of visualization. I put mind maps here, but it's some sort of visualization of where we're going, looking at the features, how it's used, workflow, data flow, risks we're discovering, environments we're looking at, things of concern, things that, for example, are supposed to work and not supposed to work. We want to make sure that that's covered. And then we want to report onto dashboards to share this information with our stakeholders and to help build these dashboards. Of course, you got to feedback early and look at what type of information, insights does the stakeholder want. And pretty much after every session of testing, we update this and update this and update this, and we adapt before we do the next thing. So you are always asking the question, are we there yet? Do I have enough information? Can you use what I've got? Can users do what they need to do? What doesn't work that matters? Have all the claims that matter been met, or are there some that haven't been met? And then we adapt. And when we're starting, we don't know the answer. And there's a beautiful way that is called the Newton-Raphson method of solving differential equations. And it's a beautiful, beautiful, beautiful approach. It's an iterative approach to solving complex mathematical equations. And what does it do when it starts? It says, guess. Take a guess. And you might guess this is important. Try it out. Loop it back to your stakeholders and say, am I going the right direction? So in math, you start with a guess, and eventually you converge on a good answer, but you start with the guess. I think the guess, the more you know, the better your experience applies to the project. You might start with a pretty good guess, but you don't have, in testing in the dark, you don't have a strong basis for testing. So we guess and we adapt, and we do reality checks frequently. And as we go, we learn more, we adapt, we focus on the things that matter, and we just keep going and going. And this basically converges and, as we say, illuminates the project as we get further along. Anyhow, I want to thank you and wish you the best day, and I'll be glad to take any questions. Thank you very much.